Hello everybody and welcome to the Epic Flight Academy. This is the Private Pilot Ground School course and my name is Mike Thompson. Now, I don't know about you, but have you ever felt a little bit lost sometimes? Well, we probably all have, and the topic today is the basics of the VOR. The VOR is what we use for navigation to help us not become lost as we fly around the country in our beautiful airplanes. Now remember, when you're studying this course, there are three parts. The first part is you must be studying the material and the related resources in Epic's online course. The second part is to view these videos in parallel to that course. And as I will remind you a couple of times throughout this video, number three, please review all of this content with your flight instructor. Now, we want to talk about VOR basics. And in previous videos, we have discussed the three primary ways to navigate. Do you remember what those were? The three primary ways to navigate are pilotage, dead reckoning, remember that's D-E-D, deduced reckoning, not D-E-A-D, dead reckoning, and electronic navigation. Now when we talk about electronic navigation, the VOR is a very popular electronic resource to navigate. So let's start by defining what we mean by VOR. What we mean is very high frequency, that's the V, very high frequency, that means it's in the VHF band range. So it's VHF equipment. Very high frequency, omnidirectional. Omnidirectional. Omni means all, and in this case it means all around, or in navigation, 360 degrees omni, and R means range. So VOR, very high frequency, omnidirectional range. When we look at them, we see that there are three types. There is the traditional VOR, there is the VOR TAC, and then there is the VOR DME. We have those three types listed here. And right next to them, we have the symbols shown for those three types. The traditional VOR is just a six-sided shape, and the VOR TAC is a VOR TACAN. Now, TACAN means a tactical aid to navigation, and that is used by the military, and that is used in the UHF range. That's a VOR TAC. And then the third one, and you see the symbol here, that is our six-sided VOR with a square box around it, and that is a VOR DME. Those are the three types. Now, let's take a moment and just discuss real quickly how this thing actually works. It works with two pulses. The first pulse is the omnidirectional pulse. Now, that's interesting because the O means omnidirectional range. This is an electronic pulse that goes out in all directions. The second pulse is a sweeping beam. Now, that sweeping beam is at the 12 o'clock position, or on the VOR, that would be 360 degrees magnetic because VORs are oriented to magnetic north. That sweeping beam is at 360 when the omni beam pulses. That sweeping beam then continues on around, and when it is picked up by the receiver measures the time difference between that omni beam and the sweeping beam. And the longer that time distance, the further that receiver is around that 360-degree circle. And that's a very simple explanation of how those two pulses work. Now, when we navigate, we think of ourselves as being on a radial. So my receiver can determine the radial between the pulsing beam and the sweeping beam. And let's say, for example, in our example here in the online course, we are on the 050 radial. And you see that outlined here in heavy blue or dark blue. Now, if I am on the 050 radial and I have a TACAN or a DME, I can also determine my distance from that station. Now, the way we think of radials is, I want you to think of that VOR, VORTAC, or VOR DME as a city, and that 050 radial is Highway 50, heading northeast out of town. Now, if I am driving out of town, away from town, or from town on Highway 50, my heading is 050 degrees. Now, this is interesting. What if I were to turn around? Oops, I forgot my luggage. I need to turn around on Highway 50 and drive back into town. In other words, I'm going to take that radial 050 back toward that VORTAC or VOR DME. Now, I am still on the 050 radial, but my car is now headed southwest 230 degrees. And the same is true of the airplane. I can be on that 050 degree radial and flying into town or into that VORTAC heading 230. So I want you to notice on our diagram, there's a tiny error. It talks about heading 050, and it says we're inbound on the 050 radial. Do you see that? If we were inbound on the 050 radial, we would not be heading 050, we would be heading 230. Now look on the southwest end of our example here. Do you see radial 230? It says heading 5050 if we're inbound on the 230 radial. Now that is correct. Inbound on the 230, I'm heading 050. What would I be heading if I were outbound on the 230? And if you're thinking 230, you are exactly correct. So let's take a look at this next diagram. And we want to see that, in fact, there are some advantages and disadvantages to the VORs. Now, we just mentioned a couple of the major advantages, and that is 360-degree omnidirectional navigation, and if it's a VORTAC or a VOR DME, I can also get distance. That's fantastic. The major disadvantage to VORs is the fact that they are VHF. Remember, they're in the very high frequency range, and those frequencies are line of sight. Now, in this diagram, take a look at the aircraft that is off to your left. Notice that this aircraft can only receive that VORTAC out there in the Pacific Ocean. It's not going to receive that VORTAC over there on the African continent because these VORs are line of sight. Now, take a look at that aircraft that's off to your right. That aircraft will only receive that VORTAC over there on the African continent, and because it's line of sight, cannot receive that VORTAC out there in the Pacific. Notice up at the top of our example, there's an aircraft in that pink overlap. That aircraft could actually receive both of those VORs or VORTACs, and by the same token, finally, that aircraft in that white space, because these VORs are line of sight, it cannot receive either one. Now, when we look at VORs in the United States, we see that they are classified into 3 classifications, and we're showing that here. They're classified either as terminal, that's a T, low altitude, L, or high altitude, H. Now, the reason for those different classifications is that they have different wattage outputs. In other words, they have different amounts of electrical power that they can transmit into space. And that determines how far away they can be used. So the terminal VORTAC, low power, the low altitude VORTAC, medium power, and that high altitude VORTAC, high power. Now let's take a quick look at the equipment that is involved with this system. The equipment is both ground-based and airborne. Now, in the diagram here, or the picture here, you can see from the online course, this is what a VOR or a VORTAC or VOR DME looks like on the ground. It's a round building and it's got that cone-shaped transmitter up on top of it. That is what is sending out that omnidirectional pulse and that sweeping beam that we talked about earlier. The airborne equipment is what is airborne in your aircraft. And it is basically 2 parts. There is the receiver, and you can see a picture of that here. The receiver is what we use to dial in that VHF frequency and select that VOR signal. And then the second part is the navigational instrument itself. And you can see a picture of that here. Now, I want to blow up the picture of this instrument and take a little bit closer look at it, because there's 3 key parts that you and your flight instructor are going to want to review. The first one is called the OBS selector, and you see that in the lower left, and it's a knob that you turn and it says OBS. That means Omni Bearing Selector. Well, what's the OBS? What's an Omni Bearing Selector? It means I can dial this navigation instrument and determine which of those 360-degree radials I would like the instrument to tune into. The second thing that you need to see is the CDI, or the needle. CDI, here's another big term, course deviation indicator. Or you want to keep it simple, we just call it the needle for short. And then finally, the third thing is the to from flag. And you can see that here in the blown up picture. The to flag is currently active because that white triangle is showing next to the to. If from was active, that white triangle would be down next to the FR for from. So, how about a simple review question to wrap this up? Can you name the 3 types of VORs? And if you said VOR, VORTAC, and VOR DME, you got it. How about the 3 classifications of VORs? And if you said terminal, low, and high, you got it. Well, folks, that's a wrap for VOR Basics. Join us next time.